us take another example in signal flow graph problems. Look at this problem. So in this problem, I have input here R and here I have output. Now this problem is example for most complicated systems. In process systems there are interactive systems. So in interactive systems you can find this kind of signal flow graphs. Now R is input and C is output. So here I have some forward path here, another forward path here, and we can have different kinds of things. Now if you have any complex problems like this and how to solve. So in this particular problem, if you closely observe, there are 6 forward paths available, and for all forward paths we need to find path gains, and also you can find what are the individual loops. There are 3 individual loops available, and we can find out what are the non-touching pairs, 2 non-touching, 3 non-touching, and so on. We can substitute all these things in the formula, then we can find out the transfer function. Let us look at what are the forward paths that are available. I said 6. What are those 6 forward paths? Let us take the first forward path. So here I can start from R, I can go to x1 and x1 to x2 and x2 to x3, x6 and C. So this completes one forward path. And what is the loop? What is the path gain of this forward path? It is G2, G4, G6. So we can see here it is G2, G4, G6. Similarly, because the signal flow graph is symmetrical, okay, we can find one more forward path in the bottom side, that is R, and we have x1 to x4, x5 and x2 to C. So R to C we have another forward path. So its loop gain is from path gain we can see here, that is you have G3 and G5 and G7. So these are the, so upper one is one forward path, bottom one is another forward path. Now we can take one more forward path also by starting from R to x1 to I can go to x2 to directly x5 and x6 and C. So this is another forward path. So if you look at all the gains here, the loop gains are, we can find out as a G3, G1 and G7. So these are the 3 forward paths, and the other 3 forward paths are. So similar to the third one, fourth also we have, because it is symmetrical. So it starts from R to x1, x1 to x4, x4 to x5 and x5 to x6 to xc. So this is another forward path. What is its loop gain? So loop gain goes like x8, x3, g8, g3 and as well as g6. Because when you look at this forward path, you can find out what are the gains that are available, then simply multiply them to get the path gain. So what is the last one? If you closely observe, you can find out the 5th and the 6th forward path. Sometimes when you are solving the problems, so you may not find that. So all possible combinations of forward paths we need to take into consideration. So what is the 5th forward path? Right. So we can start from R, you can go to x1 and x1 to x2, x2 to x5 and comes back to x4, and you can go to x3 and x6 and C. So this forms again like this, and going up there is one reverse, it is coming and it is going to x5, x3, x6 and C. So this is a one forward path. Symmetrical to this we have another one, we can easily find out, that is you can start from R and you can go to x1 and x1 to x4 and x4 to directly x6, come back x3 and come back to x2 and x5 and we have x6 and finally it is C. So this again forms a loop, like it looks like a loop but it is not loop, it looks like loop but it goes to the back. R to C, this is another forward path, and from this forward path you can find out what is the loop gain. So we have minus G3, G8 and also we have H1, G1 and G5. So this is the 6th forward path. So next we have individual loops. So from this signal flow graph, it is very clear, we have one loop on the top and one loop in the bottom, and we can take this 8 shape, this is also another path. another individual loop. So the first loop is x2 to x3 and back to x2. So minus g4 h1. And similarly the second loop is the bottom. So what is this bottom? The bottom is x4 to x5, x5 to x4, which is minus g5 x2. And similarly this 8 combination, as shown here, we have 8 combination like this. So this 8 combination, if you multiply all the loop gains, then you will get the third loop gain, which goes like we have h1 h2 and also g5 g8. If you multiply them, you will get the third individual loop. So from all these individual loops, we can cross check, we can just check L1 to L1, L1 to L2, do you have any common node, and L1 to L3, do you have any common node, L2 to L3, do you have any common node. So by this combination, then we can find out two non-touching pair. There is only one two non-touching pair, that is L1, L2. So because L1 is from this signal flow graph clear, L1 is a top and L2 is bottom. These two are non-touching each other. So non-touching means they don't share any common node. 3 non-touching pairs, not possible. If you cross check all these things, L1, L2, L3, it is not possible because the L3 will have all the nodes of L1 and L2. So 3 non-touching pairs are not possible. So we have forward paths, 6 forward paths, and we have 3 individual loops and 2 non-touching pair. By taking all these values, loop gains and forward path gains and non-touching pair gains, we can substitute in the Mason's gain formula to find out what is the overall transfer function. Let us look at what is the overall transfer function. C by R is equal to, what is the numerator? We have 6 forward paths. Therefore, delta 1 G1 plus delta 2 G2 plus delta 3 G3 and so on up to delta 6 G6 divided by delta. Delta is the determinant of the graph. So we can write the delta here. It is 1 minus. So the first, initially we should take all the individual loops. So individual loops are L1 plus L2 plus L3 plus 2 non-touching loop pair. So we have one such pair, that is L1, L2. So this gives the complete delta. What is the delta 1? So delta 1 is the determinant of the graph after removing all the nodes of the first forward path. We know the first forward path from the signal flow graph. The first forward path is like this. Then what about the remaining individual loop? There exists one remaining individual loop in the bottom. So with that individual loop, I can get the delta. The delta is a delta 1. The delta 1 is, we say it is 1 plus L2 or 1 minus of L2. Then you know L2 what is value, we can substitute here to get the delta 1. Similarly, what is delta 2? So delta 2 is the determinant of the graph after removing the nodes of second forward path. So second forward path is the bottom one. So if you take the bottom one, remove all the nodes, still there exists top one individual loop. Therefore, it forms delta 2 is equal to 1 minus of L2. So, delta 2 is 1 minus of L1, delta 1 is 1 minus of L2. So, for all delta 3, delta 4 and up to delta 6, no graphs exist. Say those values are all ones. Now, you substitute all these things in the formula, then you will get the overall transfer function. The overall transfer function goes like this. So, C of S by R of S is G2, G4, G6 into 1 plus G5, H2 plus G3, G5, G7 into 1 plus G4, H1 plus G1, G2, G7 plus G3, G8, G6 minus G2, G1, H3, G8, G6 minus G3, G8, H1, G1, G7. This whole thing is the numerator. Divided by denominator is delta, that is 1 plus G4 H1 plus G5 H2 minus H1 G1 H2 G8 plus H4 G1 G5 H2. This is the overall transfer function of the given signal flow graph.